Hey everyone, it's Mr. Martin here again. We're going to do page 220, numbers 3, 9, and 17. This is in chapters 5.3. So we're going to do problem number 3, 9, and 17. I'll probably do another set, so look forward to for later problems. But these are really, really important. You guys need to understand the first derivative test, the concavity test, and how to find points of inflection. So the first thing we're going to do is our first derivative test to determine local extrema. Number 3 is an easier one. We can find our derivative pretty easy. Y prime equals 8x cubed minus 8x. So there's our derivative. Now in order to do our derivative, or to find our extreme values, we want to do a sign chart. And this is going to be our y prime. Notice this is called y, so I called that y prime. Factor out, or we're going to make the derivative equal to 0 to get our critical points. 8x cubed minus 8x equals 0. So right away I look and I can factor out an 8x, and this gives me x squared minus 1 equals 0. So our 8x is going to give us just an 8x. X squared plus 1 gives us x plus 1 times x minus 1. And then what we do is we make each one of these things equal to 0. So this one right here is going to give us a 0 at x equals 0. This is going to give us a 0 at x equals negative 1. And then this one right here is going to give us a 0 at x equals 1. So we come over to our sign chart and we put in a 0, we put in a 1, we put in a negative 1. So up here, remember, all we're testing is the sign of each one of these numbers. So we're not worried about what the actual number is yet or anything like that. We just want the sign. So we're going to pick good numbers. So the first interval is negative infinity to negative 1. So we're going to plug in any number in between there. I always go negative 5. So negative 5, that makes that negative, and that negative. So a negative times a negative times a negative, those are all going to be negative. So that interval is going to give us negative. Remember, we put this y prime there so that we remember which one we're plugging it into. This is our y prime, and the big confusion is we might think we're plugging it into our original function. And we do eventually plug it into our original function, but that's once defined the maximum value and the minimum value. So in between negative 1 and 0, we're going to pick another point. I say 1/2 is a good point, so sometimes I'll write it down under there and I'll be like, okay, 1/2, plug it in there, positive, positive, and then this one is negative. Oh, sorry, it's a negative 1/2. So negative 1/2 gives us negative, positive, and negative, so everything in there is going to be positive. Over here, now we plug in 1/2 and we get positive, positive, and negative, so everything in there is going to be negative. Then we plug in 1,000, positive, 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 so everything there is going to be positive. So we look at here, we are decreasing right here, increasing right here, decreasing right here, and increasing right here, and that's what we're talking about, our original function. Therefore, since our original function was decreasing and now it's increasing, this is going to be a minimum. Because it was increasing and now it's decreasing, this is going to be a maximum. Because it was decreasing and now increasing, this is going to be a minimum. Okay, now we want to look at end behavior. This one right here is decreasing, so it's going to be like that. That's our end behavior. Is the function on the left-hand side is going to be coming down like that, and then increasing up here. So this means we have one absolute min. Somewhere in there. So we're going to have to test those points in there to see which one of those is going to give us our absolute min. So remember, we're always going to go through, and this question didn't say to justify, but I'm going to put that on here. It actually said support your answer graphically, and I'm not really worried about that. It does say identify any absolute extrema, so we want to plug these in. So we got f of negative 1, y of negative 1 is going to give us 2 times negative 1 to the 4th minus 4 times negative 1 squared plus 1. This gives us 2 minus 4 plus 1, which gives us negative 1. Then we're going to plug in our next point, which is 0, y of 0, which is awesome. I like that one. That gives us 0 minus 0 plus 1, which is 1. And then our last point is going to be at 1, y equals 1, or y of 1. And that gives us 2 times 1 to the 4th minus 4 times 1 to the squared plus 1. So this gives us oh, also gives us negative 1, which we like that because then we know we don't have to decide which one's the absolute minimum. They're both the absolute minimum. So if we're gonna write this out as a justification, I'll write it down right here because we want to memorize this test. We have an absolute minimum of negative 1 at x equals plus or minus 1 because y prime changed from negative, oh man, running out of room, negative to positive at x equals negative 1. Oh, x equals plus or minus negative 1. Okay, that gives us our value. So that answered 3 questions. It answered what is the max minimum, where is the minimum, and why is that justified that. Now we just want to write one more sentence. So there's one sentence. Obviously, if we are writing this on the AP, we're going to want to write it much more clear than this, not try and squeeze everything in. But we have a maximum, and this is just a local max of 1 because y prime of x, or y prime changed from positive to negative at x equals 0. So there's our 2 answers. We have 1 maximum and 2 minimums. That'd be a great test question right there. Remember, the sign charts are our work. Our justifications are this sentence. Memorize that sentence. You want to have that sentence memorized. All right, the next one says use concavity test to find concave up or down. So anytime I see anything about concavity, I always think second derivative, y double prime. Okay, so I know right away I'm going to have to do my second derivative. So I start off with my y prime. This gets me 2/5 x to the negative 4/5. And then the derivative of 3 is 0. Now, second derivative, y double prime, is going to be negative 8/25 x to the negative 9/5. I know fractions and negatives, they are horrible. Dang you, algebra. Alright, so make this equal to 0. Now, to say the second derivative is equal to 0 gives us negative 8 over 25 x to the 9/5 equals 0. Now, technically, there nowhere is that thing equal to 0. But if we look at this, we also can see that it is undefined at x equals 0. So that would be one of our critical points right there. So we're going to do our sign chart for our second derivative, y double prime 0, plug in negative, let's think of an easy one to do, 1/5, so negative 32. That's going to give us a negative divided by negative, that's going to be positive. And then plug in a positive 32, and that gets us a negative over here because it's a negative divided by a positive. Alright, so I'm looking at here, and I got concave up from negative infinity to 0, and then concave down from 0 to infinity. Now I do want you guys, if you guys are watching this right now, I would plug this into the calculator and see what it looks like, what the graph of this looks like, because there is a chance that this may not be a point of inflection. This question doesn't ask that, but this is something that you might want to look at. So I'll let you guys do that on your own. Okay. Now the next question does say find the point of inflection. So if we were going to go do this problem right away, I look at it and I go, oh, this is going to either be product rule, which we don't want to do product rule, but if we just multiply that through, this would give us x to the 4/3 minus 4x to the 1/3. Now it's much easier to do the derivative of that. Y prime equals 4/3 x to the 1/3 minus 4/3 x to the negative 2/3. Y double prime gives us 4/9 x to the, what is that, negative 2/3 minus plus 8/9 x to the negative 5/3. So our second derivative is kind of an ugly second derivative. We've got 4 over 9 times x to the 2/3 plus 8 over 9 times x to the 5/3. Just to make this easier for us to find or equal to 0, I'm going to do common denominators, which means I have to multiply this one by x to the 3/3 and this times x to the 3/3. Alright, so this gives me 4x over 9x to the 5/3 plus 8 over 9x to the 5/3. Common denominator says we can combine that in 1. 4x plus 8 all over 9x to the 5/3. Okay, so now we set this equal to 0. Remember, the top is going to be 4x plus 8 equal to 0. That gives us x equals -2. And then the bottom is 9x to the 5/3 equals 0, and that gives us x equals 0. So those are our critical points for our second derivative. So y double prime, we got -2 and 0. Plug in any points we want into here. Okay, if we plug in a -5 right here, -5, that's going to be negative. This is going to be negative, so those are all positive. Plug in a -1. This will be negative, this will be positive, so that will be negative. And then plug in a 1, this is positive, and this is positive, so those are positive. So we got concave up, concave down, concave up. So this one is a point of inflection. We have a point of inflection at x equals -2 and at x equals 0. We do have to go back in here and make sure that this works out in here. So we plug in -2 into there. -2 gives us, this comes out to 6 cube root of 2. And then you plug in 0 and you get 0. So these are going to be our point of inflections, our 2 point of inflections. And I would definitely, just for your own help on here, I'd look at this on a graph. Look on your calculator. So you guys can identify these points of inflections on there. All right, thank you guys. As always, if you have any questions, send me an email, and good luck.